All right, so the votes are in. Let's see what the actual answer is. We are trying to make a conic section where the definition is all the points that are the same distance away from the directrix, some line, and the focus, some point. So I gave you a focus and a directrix here, and let's put the easiest one in there. I need a point that is the same distance away from both of those. Okay, that would be the point halfway between them, halfway between that line that connects to that perpendicular line. So there's that easy point. Now let's do the next one. I'm using my little pen here as a distance measurer. I have, try to move it over. Perfect. This distance. If I just move this straight to the right, maybe like right here, I'm still the same distance away from the directrix, but I'm further away from the focus. And that's not our definition. I couldn't put a point right here. So to adjust this though, I just need to move my point up a little bit to balance the fact that I'm closer to the focus now and further away from the directrix, right? So I move to the right, the directrix is the same distance, so directrix is whatever it is, 2 centimeters, but the focus is further away, it's not 2 centimeters anymore. So if I move up, I'm getting closer to the focus and further away from the directrix. So one of my points I could rationalize maybe is right there. Okay, if I took a ruler and measured from here to here, and from here to here, they should be the same. And again, I'm eyeballing this, but same argument if I go to the left. If I go to the left, I'm the same distance away from the directrix, my pen is, but I'm further away from the focus, and that's not what we want. So if I just move up a little bit and shrink that distance to the focus, I'm closer to the focus now and further away from the directrix, I would get another point that fits the bill. Maybe something like that. The distance from here to here and the distance from here to here would be the same. Okay, what if I went further away? If I went further away, okay, that's pretty far away. I'm definitely far away from the focus, and I'm too close to directrix. So to make those distances the same, I would have to go up again until those distances are the same. And I'm going to try to eyeball this maybe right here. If I measured from here to here and from here to here, those distances would need to be the same. Not too bad. Same argument if I went over to the side and did it. So I'll put that same one over maybe like right here. And hopefully you guys see if we do enough of these points, we're going to get the first one that we're talking about. And there's a reason we did completing the square. It would be a parabola. One of the definitions of a conic section of parabola is the set of all points that are the same distance away from the focus, which is inside of our parabola. If you want to think of it like that, this is a parabolic shape. The focus is on the inside, and some line behind it called the directrix. So all these points are the same distance away from here to here and from here to here. I'm going to go ahead and give you one of the little pieces of information on this little note. This distance we're talking about right now is 1 over 4a. That's how I could find it. And what is 1 over 4a? What is a? Well, we'll get into that. But the distance from here to here is 1 over 4a, and the distance from here to here is 1 over 4a. That's how far we get to get from this middle point to the focus and then to the directrix. Okay? We're talking about a parabola on this Nearpod. Moving on.